Okay, perfect. So let's get started. If someone else joins later, it's okay. Let's get started with the presentation. So thank you all for being here. My name is Cristian Melendez. Today, I don't have my camera on because we are on my OS here with Marco Schutz, one of the professors from the computer science department. And today is the last day for the final workshop of the seminar TA for professors, TIA for IA, like they called it. And today is going to be a special workshop because we're going to get very involved with coding agents. So a lot of professors here in UPR do not know how to code. So this seminar was not like announced to all the professors in the university. It was targeted for professors from the computer science department. So today we're gonna talk a little bit about model context protocol and specialized AI coding agents. These are the objectives for the workshop of today. We are first gonna start with MCP and how you can set up an MCP server. In the last workshop, we talked about MCP, but it was a little bit more related to theory and how it works, but we didn't have like a live demo of how to implement an MCP or how to install it or how to use it. So today we're gonna do that. We're also I'm gonna show you one MCP server that I implemented, following the documentation that they have. And at the end, we're gonna, show you some coding agents and how you can integrate MCP servers to them, how you can provide them access to them. So first, we're going to talk about, this is the agenda. I'm going to do a little bit of a recap or a summary of the first three seminars so that you understand from where we began to where we are right now. From there, we're going to talk about model context protocol. I'm going to show you three different AI coding agents. And at the end, we're going to take some questions. So Edgar is on the chat. He's going to be available to answer your questions on the chat. And at the end, we're going to take a few minutes to answer your personal questions about it. So in the first workshop, we talk about prompt engineering. We did like a 30-minute session of prompt engineering and how to do effective prompts. From there, we show professors how to create their first custom GPT using ChatGPT. And then from there, we show them how to provide these custom GPTs files so that the AIs can use these files as reference to answer questions from the students. And from there, we have been meeting with a few professors to help them improve these assistants and to make them better. On the second workshop, we talk about a little bit of different tools that professors can use to detect if some content was generated by AI. We also showed them that students can use now other tools to humanize that content generated by AI. And from there, we went to image generation and presentations, tools that you can use to generate images and presentations using AI. It facilitates a lot the process. And for example, this presentation was created using Gamma.app. Is one of those tools that we show on the second presentation that allows you to create presentations using AI. You just give it an outline, and he helps you create the whole content from it. Last Friday, we did the third workshop in which we discussed how important is context for AI. How AI needs more information that it currently have to perform the task that it was assigned. We discussed how retrievable augmented generation works, basically a vectorial database that is specialized for AIs to find quickly information that they can use to provide more context for their prompts and the tasks that they have. We talked about MCPs, but it was a really small talk. We didn't show any concrete examples or how to use it explicitly. So we're gonna do that today. And we also discussed ChatGPT Actions. ChatGPT Actions is the way in which you can provide access to the ChatGPT models to different APIs, different libraries, and different tools outside of what ChatGPT currently have. And that's basically like the other side or the adversary of what MCPs are right now. And today we're gonna go for MCPs, so you can see the difference and how MCPs has made all this process a little bit faster and easier to integrate that using ChatGPT Actions. So for those who don't didn't attend the third workshop, in that workshop we talk about this, the theory, what the model context protocol is, and it's basically a standard, an open source standard that was created by Anthropic. Anthropic is the company that created Claude, and the goal for this standard is that using this standard, any large language model or any agent can connect to different servers that provide multiple tools to these agents. And it's really important because now you have a structured way of integrating multiple tools at the same time. In the earlier times, we had to, for example, with ChatGPT Actions, we have to create a custom connection to each tool or to each function that the AI agent was going to use. And now with this new standard, we have companies creating very big servers with a lot of functions and a lot of references and a lot of different tools that an AI can use with just one setup, with just one connection. It's pretty easy to connect. At least it's easier than using ChatGPT Actions and other protocols like N8N and Zapier, which is good because this will help us adopt more technologies and more functions and more tools for our AI agents in a faster and easiest way. So something that these servers do is that they separate the AI agent logic and the data source connections. So basically how this works is that an AI agent will receive an input from the user task, and based on the task that is assigned by the user, the AI agent can decide which tools to use and which ones it doesn't need. So it basically allows the agent to go to his toolbox and see what things he can use to answer all these prompts that are being sent by the user. So it's easy in terms of, it's a plug and play extensibility. I'm going to show you how you can integrate MCPs to your different AI agents. This is going to be later in the seminar. And, if you're more interested on seeing the documentation of MCP, you can go to this link. They have a very extensive documentation. And, this standard has been adopted by a lot of companies already. As you can see here in the photo, in the image at the left, you can see that multiple companies already have created MCP servers implementations. And it's also pretty straightforward to create your own MCP. So we're going to see that later. So this is how MCP works. You have an AI application, an AI agent. And as you can see, you can connect that AI agent to different MCP servers. And it's pretty straightforward in terms of if you compare it with ChatGPT Actions. And I think that at least in 1 or 2 months, you will see how basically most of the companies already have an MCP server. This has been running around for 2-3 months, maybe 4 months, and we already have a lot of different MCP servers implemented that you can use. We're going to see a few of them later. So as I was mentioning earlier, before MCP, you have to create a unique connection to each service that you wanted to use for your AI agent. And the most complicated part was that each connection or each implementation was unique, was different. You have to do a lot of research to see how you can connect each API to your AI agent. So it was very time consuming. And now with the model context protocol, like you have to just follow the standard, and all the servers that are already implemented, they follow the same standard. So it's a lot easier to connect MCP to different services. So to implement, no, this is the architecture. So MCP has this architecture. This is how they implemented, for example, for security. This is very important. So basically how this works is that you have a host, and the host is usually Claude, Cursor, Visual Studio Code, ChatGPT. The host is the program that sends that sends the request to these tools, is the program that communicates with the user. It manages the user inputs, the interactions. It's the one that initiates the context request, and it's the one that at the end it receives all the different data from the servers and returns the final response to the user. The MCP client is the one that creates that connection between the host and the server. Usually, this MCP client goes installed in the host machine, and we're gonna see an example of how this works. And the MCP server is the specialized servers that provide different tools and references and documents to the host. And here you can see a more visual way of how this architecture works. As you can see, the host is usually an AI agent. The client, it's different applications. For example, it could be Visual Studio Code, a client installing Visual Studio Code, or different softwares. We're going to see a few of them later. And as you can see, you can have MCP servers running on the internet. Because this is a server, you can just host it on Azure or AWS, and you can just give your client the URL, and you will be able to connect to it. Or you can run MCPs locally on your computer. Today, we're going to do that. We're going to be using Docker to do this. And you can also run the MCPs directly on your computer. You don't necessarily have to use it with Docker. But usually with Docker is easier in terms of launching everything. It's more secure, and it's usually the easiest ways to do it. So here you have like another example of how this works. As you can see on the top right, you can see the MCP host. Usually it's Claude or ChatGPT or Cursor, which is one of the IDEs that initially started all this. And as you can see, you have this MCP client, which is just a program that you can tell basically how many MCPs that agent will use, and we will see that later. And usually when you go to the documentation of MCP, you will see that they compare MCP servers to a USB-C port, in terms of that you can basically connect everything using the same standard or the same plug. And from there you have multiple new functions and features that you can use for your agent. So advantages of using MCP is pretty standardized. Here, since we're using open source, approaches, the interoperability is going to be huge. Like every company will have their own MCP servers. Everyone can implement their own MCP servers. And once those MCP servers are created, like everyone can use them obviously if you share them. And it will allow to integrate basically any agent to any data source or any features that you can implement using this standard. And something pretty important is that every time you're going to use an MCP server tool or function or whatever, they will ask you for basically permissions to use that, and it explains to you that the MCP server is going to perform this action. Are you sure? So they are pretty strict with how you can perform actions using MCP servers. And if you read the documentation, you're going to see that this is kind of a priority right now. So if you compare MCP with ChatGPT, you will see a lot of differences in terms of, for example, interoperability. Like ChatGPT actions, you can just use it with ChatGPT and OpenAI. And it's funny because if if you go now to ChatGPT, they are allowing users to connect their own MCP servers to their ChatGPT agents. But for now, you can only do it through the API and through programming. You cannot connect yet your agents to MCP servers through the ChatGPT interface, but you can do it using their API. So if you're a good programmer and you know how to call OpenAI API, you are allowed now to provide access to MCP servers programmatically. So in terms of flexibility, ChatGPT Actions also has a lot of constraints in terms of how you can implement this. MCP is more flexible. He's very adaptable because you have more options, and you have a lot of more documentation from the open source community. In terms of scalability, it's the same. I think that MCP is a lot better than what ChatGPT is doing right now. And security, I think that it depends how you implement ChatGPT Actions. ChatGPT Actions uh, have three different ways of implementing the security. You have, in terms if you're using an API, you can just use tokens, API keys, whatever, or you can use OAuth. So it depends. If you use OAuth, it will be pretty similar to what MCP does, because usually MCP force you to use OAuth or at least API tokens. But in ChatGPT, they allow you to not use anything at all. So it depends on how you want to implement it and how secure you want to implement this. And in terms of the ecosystem, since MCP is an open standard, obviously it's going to grow faster in terms of how the community adopts it because it has less limitations. ChatGPT is owned by OpenAI, so basically the only ones who can provide new features and help with all this development are OpenAI employees. So let's see now how you can install your first MCP server. It's pretty straightforward if you know how to program and if you are familiar with how all this works at the beginning. It's going to be a little bit challenging, but that's why we're here. So you have like different options in terms of how you can install your MCP server. For example, like I mentioned earlier, you can connect your MCP server to a root server, or you have two options. If you're gonna connect a local MCP server, you can run it through Docker, or you can run it locally in your computer using npx or Node. It depends, which MCP server you're gonna use, because, for example, here we have a few servers that I'm going to show you. So since I told you guys that MCP was created by Anthropic, we're going to first start with Claude. Claude is the app. You can download it to run it locally in your computer. This is the way you can connect local MCP servers to your computer. So it's pretty similar to ChatGPT. The interface is basically the same. You can also install ChatGPT locally on your computer. So for Claude, you have a good thing about Claude. It is that it's free in terms that you can use the free version. It's pretty good. And if you want to install different servers, you go to the settings, and you can go here to developer. And in this screen, initially, you will not have anything because it's the first time you're using this. So right now, here I have 2 or 3 different MCP servers that are connected. And the way in which you can connect this is you go here to the edit config, and you're going to see that you have a JSON file that you need to configure. I'm going to show you how to do this. Let me put this a little bit bigger. Close this. Okay, so you have a list of MCP servers in here. We're not gonna see for the moment this one because this is the MCP server that I implemented myself, and we're gonna see it later. But as you can see here, we have 2 different MCP servers. In this case, these 2 MCP servers are connected to my computer locally. I'm gonna show them. I'm gonna show you how it works now. But first, I wanted to show you how this is connected in terms of how you can use this in Claude. It's going to be a lot easier using other tools, but I just wanted to show you how this is done in Claude. So as you can see, Puppeteer, this is the first one I would like to show you guys. In here, we are connecting Puppeteer to our MCP server. They have different ways of connecting it. In my way, in order to make it work in my computer, uh, you just basically install the npm package from npm. You just basically type npm install model context protocol server Puppeteer, and it will store it in your computer if you install it globally. And from there, you just need to provide, the path to where it's installed. And everything that you put in here in this file, when you open Claude, it will basically run the servers for you. And in the same way, you can do it through Docker. You can create a Docker image. And as soon as Claude is launched, the Docker image will be launched automatically, and you'll be able to have access to it. So if you have more questions, obviously I can take them later. Let me show you something real quick here so you can see how you can also do that. MCP servers, Claude, or let me first go to here. And I also have in memory. Yeah, I can go to GitHub MCP servers. I just want to show you the documentation because it's pretty straightforward to go through. Okay, perfect. So if you go here to source, you're gonna see that they have like different servers that you can use. This is the other one that I'm gonna use. Is file system. You can basically provide access to Claude to your whole file system. Obviously, you can select which files or folders it can access. But if you go to the documentation here, you can see the different functions that it has. It has these are the different tools. And at the end, you have two ways of installing this, like I mentioned. This is the way I'm using it. Using this configuration, it didn't work with me, so I have to like find a way to make it work. And this is the way that you can use it with Docker. With Docker, it's pretty straightforward. You just download the repository, you just build the Docker image, and from there, like it will already know how to start the server when you open Claude. It's a lot easier with Docker. But in this case, for file system, I use this the Node.js approach because since we are looking for files in my system, it is easier to configure in terms that you don't have to be mounting different folders to the Docker image. So at least for this case, I use the NPX approach. And for the Puppeteer, the other server that I was talking about, I did the same thing because if you do it through Docker, you will not see the AI doing its thing. So I'm going to show you what I'm talking about right now. So when you go here to the cloud application, you will see that here in this button right here, you can see the all the tools that you have available. In this case, with Claude, it's pretty easy to connect at least these three different MCP servers: Google Search, Calendar Search, Drive Search. And you have here the MCP servers that I have installed myself. As you can see, we have file system and we have Puppeteer. And if you open them, you will see the different functions that now Claude has through that MCP server. And as you can see, Puppeteer allows Claude to interact with your browser. And I installed it directly on my computer because if you do it through Docker, you will not see the Google Chrome application running by itself. So I install it locally in my computer so you can see what is happening. So you can, for example, tell Claude, go to this website and do a summary of all the documentation of the API. And I'm gonna tell it to go to call.com API because this is the MCP server that will be implementing later. Call.com is an application that allows you to connect all your calendars in one single application. And from there, you can, create this logic to allow users to basically create events on your calendar. So as you can see, this is the introduction or the documentation. You can go to Claude and you can give the link. Go to this website. You can sometimes you have to explicitly tell him to use a specific tool. So I'll be here. Website. The best thing about these dudes is that they understand anyway. So, okay, so you can tell it to use the tool. And something that is very important is that you can see he already opened the browser with the tool that we tell it to use. Let me move this here so you can see. Okay. It has different functions that he can use. He can move the whole app. He can take screenshots. So basically, it has access to the whole application, and from there he can basically do all the research. You can automate processes. I try to use it to go to uh, a website that sells shoes, and there are different companies that are blocking this kind of behavior to block bots in in events when they do new releases and all that stuff. But still, you can use this tool to automate a lot of processes. And as you can see at the right, he's reading all the documentation and he's doing the whole summary of the different APIs. And you can tell it like, okay, now do this, and basically he will have access to the whole application and can do a lot of things with it. So I installed this MCP server locally so that you can see this working. But if you do it on Docker, you will not see like the browser open. It will just do everything itself inside of Docker, and you will not be able to see what's actually happening. But as you can see, he moved the whole browser, and he can hit links. He can open other, you know, uh, tabs, and basically you get the idea. So this is the first one that you can install here. Also, you can make this MCP server available to other agents. We're gonna see that later. Okay, so that was the first one. The other one is, for example, file system. The other that was the other that I show you how to install. So, for example, for this one, this is what I did. I told him to identify the largest files on my system. I just gave it access to my user file system. I didn't give it access to the computer files. So basically, he do a search of all the files that I have in my computer. And from there, as you can see, he identified a lot of different files using the different functions that file system has. As you can see, if you go here to file system, you will see that he can read files, he can write files, he can edit files, he can create directories. So you can ask him to, for example, identify the 20 largest files in my company and move them to this specific directory or make a copy or something. And from there, you can see that he can do a lot of things with your file system. And if, for example, you're running out of storage, you can use this to identify the largest files and delete them and save some storage. And it has different use cases. As you can see, he identified the different files that are taking a lot of storage in the folders that I gave it access. And from there, like, you can then go and delete them or do whatever you need to do with that. So this is the second one. Let's go back to the presentation to see where we are. Okay, so Claude offers connection to Google Calendar, Gmail, Drive. Very easy to set up. You just literally logged into Google, and you can, have your Claude connected to all these services. For example, I can, at least in my case, I connected all my calendars to my Google Calendar. So basically, I have access to all my meetings and to all my information. And I have, this is the server that we are gonna implement later. So I'm just gonna let this for later. One MCP server that I found very interesting is the Open Memory MCP server. I'm gonna look it just to show you guys how this works because it's pretty amazing. Open Memory MCP. So I tried to install it yesterday. I didn't have the time to configure it completely. But this MCP allows you to create like your own vectorial database locally on your computer using Docker. And from there, you can connect all the agents that you're usually using to that memory. So you can have, for example, a lot of conversations with Claude, and this MCP server will take care of storing important information on the MCP server on the vectorial database. And from there, then you can connect other agents to that memory. So you will basically have all the different agents that you use connected to this database that will be storing all the conversations and all the context that you are usually using on different applications. So yesterday I installed it and I have a few issues connecting the server to my different AIs, but I just want to show you something. So you have like an front-end application on your browser running locally on your Docker container, and you can see that you have different applications that will have access to the memory that you have running on your computer. So you can connect Claude and you can, run a huge conversation about how to implement the software, and then you can move all that information to Cursor, which is one of the AI agents that we use. So it will basically create a database on your computer that all your agents can use. And it is pretty useful because you will not have to repeat yourself so much. You can make references to other conversations. So it's pretty cool, and it runs locally on your computer. So you're the only person that has access to it. And since it's using Docker, you can, modify it, and it's pretty cool how they are working with this. This is basically creating your own RAG. In the last workshop, we talked about how RAGs work. This is like creating your own RAG on your own computer, and you are the only one that has access, and you can provide access to the agents that you're using on your computer. The installation process is the same in terms of, for example, how you install Puppeteer and how you install other servers. As you can see here, let me close this. So here in Claude MCP, you will see that this is like the second server that appears on the list. So as you can see, it's getting very popular, very quick. And in here in Collab MCP, you can see all the other different MCP servers that exist. As you can see, this is a very huge library. For example, we have Figma. They already have an MCP server. You can connect your Figma designs with your agent. You can ask your agent to create new designs. You can ask your agent to pull different designs from Figma, and from there he can use them for, I don't know, a lot of different things. You can use Blender. I saw a demo of someone using Blender, and you can just tell your AI to create a 3D model of a house, and he can connect to Blender and create everything for you. You don't have to do anything, and it looks pretty uh, amazing, to be honest. Like you can just tell the agent to do whatever you want in a 3D design, and he can build it for you. And one of the libraries that is going around a lot is Zapier, because Zapier is one of the leading companies in software integration, and their server is one of the biggest one in terms of different tools that they offer. Like it has so many tools that the list is pretty long. And the way in which you can connect it is the same, pretty straightforward. It's the same documentation. You just put the URL because they already have the server running online. So you just put Zapier in the URL, and there you go. And yeah, that's how you can integrate MCP servers in Cloud. It's pretty straightforward. It's pretty easy. But we have easier ways of doing this, and is using the different coding agents that I'm going to show you now. So what is a coding agent? So it's basically an AI agent that is aware of the entire code base because it's integrated in your IDE. And I'm going to show you a different examples. But the cool thing is that running these agents is right. It's like doing pair programming. Right now, they're calling them co-pilots, but to be honest, eventually they will be the pilots and you will be the co-pilot. And they work in different development environments. So these are the different examples, the different agents that we're gonna see. We have Cursor, which was like the first one. It was the first one that started this. They basically create they clone the Visual Studio Code, the Visual Studio Code repository, so it looks very similar to Visual Studio Code. And from there, they created the chat integration to the AI agent. So there is Climb, Copilot, which is from GitHub, which GitHub is from Microsoft. So Copilot has been it was one of the last ones to join the race, but since it's integrated in Visual Studio Code is the IDE most used in the world. It's free, it's open source. And so they integrated to Visual Studio Code, and automatically millions of users had access to it. Cursor had to create their own IDE. So the adoption has been pretty good, but Copilot, like Cursor came like 1 year ago. Copilot came like, the Copilot agent came like 2 months ago, and Copilot already has a lot of users. And we have Firebase Studio, which is from Google. The cool thing about Firebase Studio is that it runs on your browser. It doesn't run on your computer, and it's integrated with all the Google services. So why does this matter? Okay, so the industry adoption of these different softwares has been pretty fast, pretty scalable in terms of how companies are using it. If you see here on the industry adoption, 41% of all the code in 2024 was generated by AI. So as you can see, basically most of the developers are using AI in some way. It could be directly through ChatGPT or using these different AI agents. And it's important that companies are expecting students and new hires to learn and to know how to use these things. So, for example, GitHub CEO says that 80% of the code will be written by AI sooner rather than later. And what he says is that the point of all this is not that we're going to replace like all the developers with AI agents. It is that now these AI agents can focus more on that 20% that is the most critical or more important part of software. So the easy stuff, the testing, the things that usually developers don't want to take care of, like these AI agents can do it now, and programmers can focus more on the critical aspects of the software that we're building. So all these things, like what bring to the conversation is that we as educational people and professors and academic staff, we have to maybe switch a little bit the focus on how we teach programming to students and how we integrate these things so that students can learn how to use them effectively. But at the same time, we have to understand that we cannot just tell the students to use these tools blindly and let the AI agents do all the work, because they will not learn how to program, they will not learn how to do requirements, how to validate that the software is correct. So we have to bring a balance in terms of adoption, but at the same time make sure that students are using critical thinking and that they're learning how software works and they can validate that the software is doing what it's supposed to do and that it doesn't put anyone in danger. So now we're gonna start with the AI agents, and the first one that I'm gonna show you guys is Klein. Why Klein? Because Klein, actually, I discovered this one pretty recently, but it's the one that allows you to install NCP servers the fastest and easiest ways possible. So to use Klein, I'm going to close this right here. To use Klein, you can go here to the Integrate Extension Marketplace. You can type Klein. As you can see, it's very popular. Look, it has 1 million downloads. And it's the same thing as GitHub Copilot. But since GitHub Copilot, like I told you, is from Microsoft, GitHub Copilot, it's already installed on Visual Studio Code, configured for you. And you can see right here, this is GitHub Copilot. It goes connected to your GitHub email, your GitHub account. So if you're a professor in the UPR, I think you have a pro version free for you. You just have to connect your GitHub account to Visual Studio Code, and you will have access to GitHub Copilot. But in terms of Klein and how it works, once you install it, you will see the logo here, and here you can see how this works. So as you can see, it's very similar to GitHub Copilot that I just showed you. And if you don't like it on the left, you can just hit this and we'll open on the right. And then we can just move this. Since I'm used to using GitHub Copilot, I'm used to have it on the right. So let me close also this. Okay. So Klein, if you go to the configurations, you can pay for the service. They have like their own subscription model, but you can also just get some API key from the different providers. As you can see, you can use Klein, which is basically paying a subscription to them directly. But you can use Claude, Anthropic, OpenAI. You can use, in this case, I'm using Google Gemini. I generated an API key from Google Gemini, and I'm using the Gemini 2.0 Flash because I think it's pretty cheap, or I'm not sure, but I think it's even free basically. So you can run all this using Google Gemini, and you will not have like to pay a lot for it. And as soon as you have your API, your large language model configured, you can start using it. So let me close this. Other very cool thing that this has that none of the other agents have is that if you go here, you have an MCP server marketplace. And the awesome thing about this is that if you are interested in connecting any MCP server, you can just hit install and he will do all the configuration for you. For example, I install file system. This is the same MCP server that I showed you guys earlier, but now this AI agent had access to it. And when you hit install button, for example, let me see if I can find someone. Browser use, Firecrawl. Well, I also have Puppet here. And for example, let's install this one, Brave Search. If you hit install, he will take care of the installation for you. So you don't have to work with the different configurations, copy and pasting code to the MCP server file or config. He will take care of it for you. Okay, so in this case, he's asking for an API key. I will not do that now because I don't have an API key for that. But you can understand like how it works. Like you have a multiple MCP servers here. For example, you have Figma. Pretty sure Figma will also ask for your API key. You have Perplexity research. If you guys, for example, like to use deep research in Perplexity, you can connect your AI agent to Perplexity using an API key. And you can then tell your agent to perform a deep research for you in your browser, and from there you can apply that deep research to your code. So as you can see, we have Blender, all the MCP servers. You have Supabase. Supabase is one of the top companies right now providing vectorial databases for AI agents. So you can install it, and you will have a direct connection for Supabase. SQLi. You have a lot of different uh, MCP servers use Postgres, Atlassian. So you, for example, you can connect your agent to Trello. Trello is one of the most used Kanban board project management tools in the industry. And as you can see, all of them are here. You can just hit install, and he will do the installation for you. So it's pretty useful, pretty quick, and pretty easy to use. Once you install all the servers that you need, you can just go to here. And as you can see here, down there, you can see the MCP servers, and you can see all the functions that it has. Look, you have file system, you have Puppeteer, the same thing that you saw in Cloud. You will see like all the MCP servers you have connected and the functions. And as you can see, they're available. So if you want to use them, you can just tell it to use it, and it will use it automatically. So uh, continuing with the presentation, we still have 1 more hour. Okay, so let's talk about building an MCP server now. How complicated it is? It's not that complicated actually. So MCP servers have three main things. They have tools, they have references, and they have prompt representations. They have other stuff, but this is like the most fundamental part that you have to understand to implement your own MCP server. And in our case, we're going to focus on tools because references are basically documents that you can contact an MCP server, and the MCP server will return that document. And that's it. So today we're going to build, I already built it. We're going to see the code and how it works. We're going to see how you can implement different tools, and then you can provide access to those tools to the agents. So one important thing about the tools is that once you create the function, you will also have to create a very good documentation to allow the AI agent to understand what each tool does, because if this is not clear, then the AI agent will not use it. So let's go to that project now. I have it, in this case, I'm gonna close client now, right now. This is the MCP server that I implemented myself. As you can see, this is a Node project. It's using TypeScript. Here we have GitHub Copilot, and it has access also. If you go here, you will see that we have access to Puppeteer file system and also Qualcomm Calendar. Right now it says it's not available because I don't have Docker running the instance, but we will get to it. Okay, so when you want to create your own MCP server, the best way to do it, I think, let me see if we can, yeah, we have it here. The best way to do it is just to clone the GitHub repository. They have a lot of quick start resources. For example, you can follow this one. The one that I implemented was a call.com MCP server, but it was using the version number 1 of the API, and it wasn't working. So I migrate the whole thing to the version 2, and now it's working. So you can just clone one of these repositories. They have a few quick start resources, and it's pretty straightforward. The one that I had was already started. I created a few tasks, modify the README. But to implement a server, the only thing you have to do is to create an index file. And in here, let me close this so we can understand better the code. So the first thing you have to do is to define the tools, the definitions. And as I told you, it's pretty important to document the description. So as you can see, this is a tool. This is one of the first tools that we will provide to Claude or to the different agents. And in here, you have the name of the tool. And if we go back to Claude, you go here, as you can see, this is call.com to get all calendars. So this is the one that we're seeing right now, get all calendars. It has a description, and the description, it must be pretty clear so that AI agents can understand what this does and when they should use it. So this is important that you do a very good description for each of the tools. And as you can see, it's pretty straightforward. You're just doing some kind of documentation for each tool. This is the second one. This is the third one. You have a name, a description. The input schema is basically what it needs from the user or for the AI agent. So it is good that you put also a description, because usually all these inputs are auto-generated by the AI agent. So based on the conversation, if the AI agent understands that it needs some of these inputs because you haven't given it to them yet, so it will ask like a follow-up questions to get all these inputs so it can call the tool. So it's important that you document this very good, because if you don't, the AI agent will not know how to create the input. So that's why this is here. So this is all the documentation. As you can see, more tools, tool definitions. We have 10 different tool definitions. This one is to get all the event types. For example, I have 2 different event types on my cloud.com. One is for AI consultations, and the other one is for a personal private one-on-one meeting with me. We're gonna see it how it works soon. And this is how you define all the tools. After that, you implement the server definition. If you haven't like implement a server before, it's pretty straightforward. You can look the documentation. We have different functions to get the API key. In this case, since we're using Qualcomm API key, you have to get it from the website. You have to generate an API key. In our case, I exposed that API key on the definition of the server. And from there, here you can get the base URL of the API, which is api.call.com v2. This server was implementing v1, but v1 is old, is outdated, so I just updated everything to the v2. You have to set up the rate of the how many times you can call this tool per second, and from there, then you start implementing the actual stuff that the API, the server is going to be using. So we have shake rate limit. You have also guard functions in terms of how the inputs are validated. So it validates that you are inputting everything correctly. This is more validation, and then we have more validation. So you can see most of this code was generated by GitHub Copilot, not me. But as you can see, it has the comments, and it has everything to validate and to explain what's happening. And from there, here are the business logic. This is what you actually can customize any way you want. But as you can see, this is the get all calendars. First, it checks the check rate limit. And from there, you can just connect to the API using different functions to connect to an API. And from there, you get the API response. You validate everything, and after that, then you return the value. This is like the logic of the connections. let me go down so you can see one last thing. This is get all bookings. Okay, I'm just gonna show you the last part, which is this. Okay, this is the routing. So we have all these tools. This is like the definition of the 10 tools that we have implemented. And basically what it does is that depending on the tool that you are soliciting or asking for, it does the mapping. So if you, for example, call come get all bookings, then the result will be generated by get all bookings, which was one of the functions that we implemented above. And in that same way, you have the calendars, get busy times, complete schedule, call come get booking, create booking, event types, get all event types, etc., etc. And that's it. Once you complete all that, this is the main entry point. So once you have built all this, you have your Docker file. In your Docker file is how you define the environment in which this MCP server is going to be running. And once you have all this configured, you can go to the README. You just build the Docker image or the Docker instance. And once this is done, you can go to your Docker environment. And as you can see, I have here my MCP Qualcomm calendar. And if you see at this name right here, if you go to Claude, you go to settings, and you go to the developer, this is the same server that we are using. And as you can see in the arguments, let's see the edit config. Open with. So this is the configuration. So you have the command, you are telling it to use Docker for this specific one. These are the arguments. The Qualcomm API key is the API key that you have to get from the browser, from the call.com application. And when, for example, Claude runs, it tells Claude that it has this MCP server running on Docker. So, for example, if we go here to Claude again, when it opens, let me show you. Right now we have a container, MCP server. We're gonna stop it. I'm gonna close it. I'm gonna delete it. Okay, so it doesn't exist anymore. And if you close Claude and you open it again, the first thing it does is read that MCP servers file. And as you can see now, the image is running automatically. And the same way, I think that when you turn off Claude, it will also turn off the Docker instance. So basically, Claude is the one that is turning it on and off. And if you go back to here, to GitHub Copilot, since it's running now, you can go here to the different servers, start server. And it's supposed to have access to it. So I know it's a little bit technical in terms of how you implement this, but the good thing is that if you are a backend developer that knows how to interact with different APIs, or you know how to implement a connection to a database, now you can, with this, you can create something very simple and allow your AI to interact with it in a pretty easy and secure way. So now let's continue with the presentation. We have one more thing to do, and from there, then we can take a few questions. So now we're gonna talk about the missing context problem in AI coding. So one of the things that these agents haven't been able to do so far is to keep consistency in terms of how they implement things. Something that you will see if you're implementing very complex programs or software is that every time you start a new conversation with them, you're gonna see that if you are not very specific in your prompt and the things that you're asking from it, uh, it's gonna hallucinate, it's gonna generate incomplete code or code that is not compatible with other libraries or other parts of your project. And it's because the AI agent only have access to the software that is running on the Visual Studio Code or your different IDEs. So for example, this is GitHub Copilot, and right now this is the the tool that has access to my code. Let me, for example, show you how this works because I know some of you have never seen how this works. But GitHub Copilot, you have three different three different ways of using it. You can use Ask. Ask is more about asking it questions about the code. For example, can you explain to me what this code does? And you can add context. And the context, this is the thing that I'm mentioning that we still have a few issues with it, is that you can provide access to it. You can provide access to, all the files that you have here, but still we don't have access to a few things that it will allow the AI to do, a better work. So for example, I provide access to index, which is the file that we were working on. And from there, you can put it to work. And he will basically analyze all the code that we have here and we'll explain to you what is happening real time. And you can ask it about how many lines the code has, if it has different security issues. You can use this to audit your code, and from there you can ask for suggestions. You can ask for multiple things. So as you can see, it read the whole code, and from there it is explaining to you what this specific software does. It's pretty straightforward, and that's the ask mode. If you select edit, this will do one specific edit that you ask the AI agent to do, and if you put it on agent mode, uh, the agent will work on your task until it's completed. So it will do a lot of iterations until it completes what you're looking for. And something very important, you have here in GitHub Copilot, you have access to multiple models. And since you're paying the $10 per month, or you have the free version because you're a professor, you can select multiple models. You can play with them. At least for me, the best coding agent is Claude. The Claude 3.7 was pretty good, and Claude 4.0 was released this last week. It's very amazing, very good with programming, and I have been, working with it for the last week, and it has me very happy because it is helping me a lot. So besides that, you have the tools here. I just showed you that. These are the MCP server tools. For example, you have GitHub Copilot for Azure, and Azure already have an MCP server in which you can get, for example, best practices. You can query a lot of these different functionalities the Azure is providing. So you can see there are a lot of them. Web search, and the built-in. Are the tools that Visual Studio Code is building for the AI agent. One of the most useful ones is problems. When you are implementing something, and for example, let me do this. So I inserted a P here. So now it appears here in problems. So now, for example, if you have code that had 10 problems, you can go here. You can attach problems. You can select one specific problem, or you can take all problems. And now this agent has access to all the bugs that in the code. And you can tell it, uh, please fix all the problems in my code. In agent mode, and it will take a look at all the problems that you have here. From there, he will read the document, index the TS, and it will solve it. He find that we have a P here that is not supposed to be there. As you can see, it iterates a lot of times. Now let me check for any other compilation errors. It checked, no problems found. Okay, perfect. So it can also run commands in terminal. It's pretty cool. Okay, so you have to hit the keep button so to select all the to approve all the changes, and that's how GitHub Copilot agents works. They are very good in terms of helping you documenting everything, understanding the code, and you can integrate many tools with it. So I just show you GitHub Copilot. I show you Klein, and the last thing we're gonna do is try to solve this. Not solve it, but at least design some kind of workaround in terms of how you can allow your AI agent to have access to all the software documentation of your code. So, for example, when you're using agents, they don't have access to the project requirements, they don't have access to style guides, they don't have access to the database schemas and design documents. They don't have access to any of the software engineering documentation that you have or you have built. And it's good to provide access to that so that the AI agent can like a more specific result and a more efficient result. So I have this software. Yeah, let's build something from scratch. It's not mandatory to use it, but it's for me it's pretty useful. And for this example that we're gonna do now, I think it's one of the best tools. And I think that if you use it once, you will understand what we're doing here. And from there, you can just do it all by yourself. So this software is called Code Guide. It was created by an AI engineer that I follow on Twitter, and he's very good in terms of how he integrates AI with, coding. And to be honest, I find the service a little bit expensive because it's $30 per month. So I bought it to see how it works and how I can integrate this on my development flows. So you don't have to pay it. I just want you to understand like the complete approach of how he does this. So uh, when you create a new project, they have a different starter kits to build something. I want to create a specific MCP server in which I can allow, for example, students to connect to that server and answer an exam or an student evaluation through the server. So what I want to do is to allow students to run a test through GitHub Copilot through an MCP server. So what we're going to do is we're going to build this MCP server. I'm not sure if we're going to be able to complete the whole implementation, but I just want to show you how you can create the documentation so that the AI agent can take all that documentation and start the implementation for you. So the documentation is going to be created by this software. It's pretty cool. So let's start by describing what we want to do. So I haven't tried this yet. I mean, creating all this server from scratch, but we want to create the documentation for it. So this is the first prompt that I created. If you can see, professor objective. This is the prompt. I want to create an MCP server that allows students to take interactive coding tests through an AI coding agent like Visual Studio Code, GitHub Copilot, or Cursor. The objective is that the students authenticate with their institutional email and student number, and from there they can ask the server for the exam questions. Then they will develop the code in the IDE and then can submit their answers through the MCP server where the professor, the one who managed the servers, can evaluate the response. It will also be good if we have an AI agent in the MCP server that communicates with the student to simulate like there is a teacher assistant providing the exam in real time. So this is something that with a little bit of effort in a few hours, we can actually build. But we have a few minutes to complete it, but we're going to start with the documentation. So this service will take this prompt, and from there, it will ask you which coding tools you want to use. In our case, since we haven't used Cursor yet, we're going to type Cursor. And we can also type Visual Studio Code. And I saw that we have Climb. So we have all these different AI agents. As you can see, all of these are AI agents. Different companies. Windsurf is also pretty good involved. But for the moment, we're going to keep with this three. So the objective of this platform is that you spend more time at the beginning developing the software engineering tools, the software engineering documentation, and after that, it will make your life a lot easier in terms of how you can ask your agents to complete the different tasks. So this app also has like an agent. So as you can see, they give you like some kind of follow-up questions. We have here 10 questions. Let's answer them quickly. Yes. We need to create some kind of UI for the professor to configure the questions. Which programming language or runtime should be supported? For the moment, Python and JavaScript, TypeScript. How should students access the exam questions via custom Visual Studio Code extension, separate web interface? Want them to connect to MCP server, which will be hosted in the web service platform like Azure or Google Cloud. What role should the AI teaching assistant play? It should work like an AI coding interview. It can help the student with hints if the student asks the right questions, but it will not give the complete answer. Grading view, for example, automated test results, side-by-side code comparison, comment threads, scoring, rubric, it's fine for the moment. Do you need to integrate with your school system? Moment, we will keep the auth very simple. They just need to provide their institutional email and their student number. Yes, admins and TAs could also be included. Please use standard UI library. And should exam submission trigger automated checks? No. For the moment, it could be manual grading or depends on how you develop the exam. And your institution data center, cloud provider. Cloud provider. Okay, so once you answer all the questions from the AI, you can generate the outline. So this is also using, I think in this case, for example, a very cool feature that they have is that they have their own like AI agent, and they ask you to connect your own API key. I did it once. I connected my Google Gemini API key, and this AI will have access to the screen and will be able to read everything for you. And from there, you can ask questions about what's happening. Okay, so here we have the authentication and authorization, like it develops the core features of the app for you. Then the app flow, the tech stack, and these are the documents that it will create for us. These are the documents that you want your AI agent to have access to it. Every time you ask for a task, it will be able to use all this documentation to develop a very specific and useful code for you. So you can create docs. And this is where I think you should now invest more time when you're developing, creating good documentation, good software documentation. And you can generate all of them. You can go one by one, but we don't have the time for it. But they can generate all the documents for you, and you can modify them in here as after they generate the documentation, and you can ask the AI to improve it for you too. So it's pretty useful. It accelerates a lot how you can create the software engineering documentation. Right now, it's creating the requirements. Well, it's creating all of them at the same time, but here you can see the requirements. So for example, for the software engineering course, this could help a lot of students, but at the same time, it will make all the work for them. So you have to find a way to balance that in scope and out of scope. The user flow, so you can see core features, and you can modify like each document specifically. You can type what you want to change. Anyway, it's not allowing me because it's generating all the documents. But when it's finished, you can modify the documents. And the coolest part about this, eventually when it finished, you can see here that it says copy prompt. In that bottom, it will create a prompt for your AI agent to pull all this documentation and import it directly on the IDE. And from there, you can ask the agent to put it whatever you want to put it, and you can ask it to put it on an NCP server or on the rules. For example, we're gonna see how Cursor use rules. While this is finished, let's go to Cursor. I'm gonna create a new project real quick. We're gonna new folder, NCP. Automated test. And we're gonna go to Cursor. So this is the Cursor IDE. As you can see, it looks pretty similar to how Visual Studio Code works because it's a copy of it. Go to projects. We're gonna open this folder, which is gonna be empty for the moment. Once you open it, as you can see, this is Cursor. You have your AI agent in here. It's pretty similar to how GitHub Copilot works. You can select different models in here. You can put it on agent mode, on ask mode, or manual mode. We're going to use the agent. And we're going to start with the development once all the documents are completed. Okay, so all of them are completed. The most important one is always the requirements. If you don't have good requirements for a project, it's going to be ugly for you if you have to make changes later. But you can as you can see, you can modify the text in here. You can ask for new things. You can do a lot of things in this software. And as right now, we're going to do this quick, and I'm not going to verify all the documentation. But the most important one is this one, the implementation plan, because this is what you will use for your agent to give instructions in terms of how all this will be implemented. So this document, you can tell the agent, let's go to work now on phase 1 of the implementation plan. You will do the first task. And with only telling that, you don't have to, provide all the context and explain the AI agent how to do it. Like you have all the documentation here available. So if you go to copy prompts, this is one of the coolest features of this app. You see that it will create a prompt for Cursor or Windsurf or Climb or other different, AI agents. So we're gonna type Cursor. Got it. I don't know if did it copy it. Yes. Okay. So now you can go to Cursor. Let me close this. You can go to Cursor and you're gonna type the prompt. Okay. So as you can see here, it's gonna go to the URL. If it finds something, it will download it. It will put it in the repository. And from there, it's gonna put it on the .cursor roles. Let's hit it so we can start doing it. So in Cursor, okay, let me change this. I'm not paying for this, so it's complaining. Okay, GPT 4.1. Okay, so now it's going to the website. It's gonna download all my documents and it's gonna put them in here in the IDE. So Cursor is specific. They have these rules, and these rules are basically things that the IDE needs to follow when it's using the AI agent. So for example, you can put rules in there that explains how you can implement something, and you're gonna see now how it works. Continue. You can run. Run. So it's gonna make the directory for me. So as you can see, we have the documentation already in here. These are the documents that we generated over there, but they're not yet on the cursor roles. Now it's gonna create the cursor roles. Anyway, this .cursor folder is the same as Visual Studio Code has something similar. JetBrains has something similar. This is basically rules for the IDE to follow. Okay, so if you go now to cursor rules, you will see that you have all the files, and you have them in a format called MDC. This is a format specific for Cursor, and as you can see here, the rule type, it says always. So every time you're gonna run a prompt here in the IDE, this rule will be attached to every chat and command on request. So on request, no, it will always be attached to it. You can select auto attach, agent requested, or manual. So if you put always, like all this documentation will always be attached to every prompt that you tell the agent. So now it has a lot of more context than before. So you, for example, can go here to add context if you want to do it explicitly, and you have all the context here explicitly. So you can put here the implementation plan, and you can tell the agent, okay, you don't have to put okay. Let's begin with the implementation of this project. Go to the project plan, and let's start with the first step. So now it's going to read the implementation plan. I don't know why we don't have Git yet. So it's going to really start from the beginning. It's initializing the Git. And now it's going to start doing the node installation. Yes. Okay, we're going to create. As you can see, it's creating all the file structures. And from there now, you can initialize everything, and you can follow the implementation plan along with the AI agent, and you can see how he will be developing everything for you. Obviously, your job as a developer now is to validate that everything is implemented correctly, that the software is secure, that the software do what it's supposed to do. And it is convenient in terms that it's a better coder than you, but you need to understand that now it's your responsibility that this code does what it does, and you have to take care of all that. Okay, so it says the environment is now ready for the next phase, front-end and back-end setup. Yes, let's begin with the back-end. And as you can see now, we have an agent that is back with all the documentation of your code. You can modify this code if you want this text. You can, spend few more minutes than I did, but explicitly document everything like it's supposed to, and then it will save you a lot of time in terms of development. And actually, if you go here to the application again, you will see that one of the ways in which they measure how good this platform is that it it summarized somehow how many tokens you save in terms of, you don't have to create prompts so long now, because you don't have to explain the AI agent every time you're going to ask for something why you're doing that, because it has access to all the documentation. So if you're using, for example, an API key, or yeah, if you're using a large language model through the API, it's going to save you a lot of money because you don't have to input so much context by yourself. And it also will save you a lot of time in terms of you will not lose time explaining to it like what you should do and what you should not do. So I think, let's see. Okay, so this is how the pros are doing it right now. Like, I have seen a few people doing something similar to this. In this case, we're just putting the documents in the rules of Cursor. I have seen other developers that what they do is that they create their own MCP server, and in that MCP server, that they put all these documents as reference for the MCP server. So the AI agent can also have access to those documents through the MCP server. So you go to for example, if you go to Visual Studio Code, here in the tools, you will see like the server definition, and you will see the different documents. So if you attach them, it will be something similar to what we just did in Cursor. That every time you run this, it will have access to the documents, and we'll use them as reference to develop the code. So uh, I will not develop this whole MCP server now because we don't have the time for it, and I would like to take questions. But I think you have a pretty clear idea of how all of this works. So let's get back to the presentation to see if I forgot something. No, that's it. So, okay, now I will take questions. Let me see here in the server. Okay, perfect. So do we have questions? You can input them in the chat, or you can talk if you want. Or here in UPRN, we have Marco. Marco, do you have questions? By what? What specifically do you like the most? Yeah, it is. Yeah, 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 I agree. For example, in MCP servers, like I just saw a few YouTube videos and I saw so much developers working on different things that it is overwhelming at the beginning, but once you get started, like you have to find your own way in which how to like specialize because there's so much things going on right now. But yeah, do you have any more questions in here? Yeah, of course. Hmm. 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 About it. Yeah, that sounds amazing. I think that that's something that with these tools it can be built. And I think it's not that complicated because in the example that I just did, what I would like to do here is that in the MCP server, you can also integrate AI models. So we can first receive the whole code, the whole project, and from there you can give all the source code to your AI agent, and from there generate the questions and send them to the students. So that's something that we can do, and I think it's not that complicated, and it would be mind blowing also for the students. Like basically you have an AI agent asking real time questions about your code. So that is something that I'm pretty sure in less than a year we will see something similar being implemented. Hopefully, we can do it ourselves here. So that's the whole goal, the whole objective of UPR bringing us to here and doing. That's a very good question. The issue with UPR is that everything runs through Microsoft, so we have to use Azure. And yeah, we have to talk with the IT team that controls Azure. I'm pretty sure that we even have like a cloud team that is under the contract with the UPR, and they told me that if I will use UPR servers, I just need to talk with them and they can deploy whatever I need because they already pay for. So it's just bureaucratic stuff. So if we get access to it and they give us the go ahead to implement this kind of things, I'm pretty sure that it's not gonna be so complicated, but it's just to ask for permissions. Mhm. 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 I have. Mhm. Yeah, I have seen that Moto has. Look, we already have an MCP for Moto. So yeah, I didn't check this, but yeah, we have actually Zapier has one. This one, I think, a model context protocol. I don't trust Zapier because Zapier charge you for every call you make to their API. So and they're pretty. It's not expensive, but it's not scalable. Like at the beginning, you're gonna see, it's pretty cheap, but if you want to scale, it's gonna be complicated. It's gonna be expensive. But we have open source MCPs. Look, we have Moodle. I haven't read the API of Moodle, but it seems like they already have something here, and I'm pretty sure that eventually we will have something pretty legit that you can model MCP servers for AI agents. Hmm? Look, here you can get assignments, get student submissions, provide assignment feedback. You have quiz management, so you can create all the quizzes and the stuff through Moodle, and then you can connect those quizzes to. So that would be amazing if we can do it through Moodle. So yes, you can be on GitHub too, and here you can see. Like if this is something that I'm pretty sure a lot of professors will be interested in, because in every workshop there is always a professor asking if we can connect this with Moodle. So I'm gonna make a little research about it and see how we can eventually look. You can connect Claude with Moodle, and I will do a little bit of research about this and see how we can start playing with it and start seeing how we can allow professors to use it. But yeah, it's pretty interesting. Okay, so if we don't have any more questions on the chat, let me go back to here. I'm gonna stop it right here. Thank you all for attending the event. This will be recorded and will be put on YouTube, so you can share it with your colleagues. And if you have feedback, I think you will receive a form. I don't know if today, but eventually you will receive it. And I think they will provide 2 hours of professional development for the attendees of the event. So thank you all for being here. We will also be providing one-on-one consultancy sessions for these kind of things. So if you want to implement something with AI, or you want to adopt some technologies about AI, you can contact me or Edgar, which is here in the chat bot in the chat, and we can have a meeting and we can discuss how we can help you implement this, for your academic task, or if you want to do some research. The UPR is already paying us for this, so it's covered. You don't have to pay anything. You just have to schedule a meeting with us, and we can help you with it. Okay. I see Omar. Thank you, Christian, for your help and this position to keep us learning about AI. Okay. So thank you all and have a good weekend.